Okay, so let's do a quick 1 minute intro about who you are. You don't have to say anything specific, and then we can get started.
Hi, I'm Jay. I'm currently a student studying Masters in Computer Science. I'll be graduating in May. So my interests are in programming, web development, and applied machine learning. Yeah.
Cool. Okay, so let's start with, where's this thing? I actually had this question. Is it this one? I thought I had the right one. Maybe I don't. 1 second. Not that. Oh yeah, here it is. Okay, so I've got some feedback to be a little bit vague about problems, so I'm going to do that here, and then you can feel free to ask what you want. So the first problem is you're going to be given a binary tree, and you're
Okay.
not going to be given it in a binary tree format. So you're going to be given three things. You're going to be given and you can write this down as well. So you're going to be given an integer n, which is number of nodes in the tree. And then you're going to be given a left child array and a right child array. And basically here, so a left child array at every index is the left child of that node. So like left child of 0 is the left child of node 0. Left child or right child of 0 is the right child of node 0. And you can have a valid number or -1, meaning you don't have a child. So let me give you one input. And basically you're asked, can you form one valid binary tree in exactly one binary tree? So here's an example.
Okay.
And you can go ahead.
Yeah. Okay. So I'll read out what you just said. So,
Yep.
so if I go to the left child array, so 0 has a left child of 1,
Mm-hmm.
and 1 doesn't have any left child. The left child of 2 is 3, and 3 doesn't have any left child. Is that right?
Yes.
And for the right child, 0 has 2 as the right child, and yeah, it goes the same like that. Am I correct?
Yes, and I'll actually write also the end time is going to be 7:20 my time, which is in like 51 minutes, just to so
Okay.
you're aware.
Mhm.
Okay, go ahead. Are you still there? Or are you just
Yeah,
thinking about it?
yeah, I'm just thinking.
Sure.
Okay. So what I can do is like, I can use a queue. Mm,
Oh, actually, screw up the time. We can go to 7:30 my time. Sorry, that's 50 minutes.
yeah, sorry.
Okay.
Mhm.
Okay,
So
use a
what I
queue.
was thinking is like, I need to return a Boolean whether whether I'm able to construct a binary tree or not. Is that right?
Yes. Yes.
Okay. So what I'll be doing is like, I'll be iterating through left child and right child arrays. Mm. So 0 is my root. Is that right?
So 0 is not guaranteed to be a root. It can be any root.
Oh. So if anything can be a root, so do I just verify whether each one has two children or not? But there should be a connection as well. Okay. Mm.
So by
So
any
if I
root, I mean like as long as you can make a tree with any one of these nodes being the root and it's valid, then that works. So like I'm not saying like with this input any node can be a root and it's valid, but 0 is not guaranteed to be the root you have to pick to make your tree. Does that make sense?
oh Okay. Okay. Mhm. Okay. So if I start iterating left and right children, and if I start with zero as my root, so zero will have one as its left child, two as its right child, and I put one and two in my queue. So for one, next, if I see one doesn't have any left child and doesn't have any right child, that's fine. So next in my queue is two. Um, two has a left child, three, and doesn't have any right child. Okay. And uh, the next in my queue is three. So three doesn't have any left child, doesn't have any right child. So I'm able to construct it. So I'll return true.
Mhm.
Um, okay. So I think uh, if at any point I find that um child already exists and I still want to construct a child, that should be false. But mm, yeah, that's how it should go. For example, if here mm, 2 has a left child of 3, and if yeah, so am I thinking the right way or like it is wrong?
So I'm a
So
little
I'm
bit
just trying to
unclear what you're. So I understand you did a BFS from zero, but my
yeah.
question to you is that works, I think, if you know the root is zero, but that's not guaranteed. Like I can move these around to where the root isn't zero, it's something else, and it's still a valid tree, right? Like I
Okay,
could
so
swap these around. Maybe the root might be like two. So
okay,
I see what
okay,
you're
okay.
saying. That might
So
work, but yeah, how would you do it if you don't know the root?
yeah, got it. So I just try to like so what I can do is like a binary tree, right? So basically I can just construct a graph, a directed, so bidirectional graph, and then I can just verify if each node has two children or not. That is one way. So what do you
So
think?
you make a graph and you verify that each
Bidirectional
node
graph, and you said like
bidirectional.
anything can be a root, right? Anything can be a root. So what I'll
Uh,
do is like,
yeah. Okay, go ahead.
so I just like construct a bidirectional graph and then pick anything as a root and then start iterating from there and just find if they have two children or not.
I see. So there's a couple things that I'd like to point out. I think so. Here, if I draw this, so you can enter the drawing thing. Are
Hmm.
you in here?
Yeah.
Okay. So basically, let me just zoom out. Or okay. Yeah. So here, if I make zero the root, then its left child is one, its right child is two, and then two's left child is three, and then there's nothing else, right? And this is valid.
Hmm.
Now, this is valid, but if I say instead of zero, I want to make three the root, now three's left child is nothing and three's right child is nothing. So it's not bidirectional because, like, if something has a left child, that child can't have a left child of that other thing, you know?
Yeah. Yeah.
So yeah. So here only zero actually works. So when I say the root can be anything, I mean like just because zero is the root doesn't mean everything else works. But you don't know that zero is the root. Like it might have been two or something. Does that make
Hmm.
sense?
Yeah.
Okay.
Okay. I have to think another way. So I just need to verify it is a binary tree. So mm, okay. Mm, how about I construct nodes, for example, construct node 0 and then put node 1 on the left, node 2 on the right, and then null. So yeah, I get what you're saying. So yeah. I got how to approach this problem.
Okay.
So how I'll be doing is I'll be just constructing nodes. So I'll be taking a strut node and then it has a value left child and right child. That's how a node is made.
Mm-hmm.
So I'll just follow this left child array, right child array, and start constructing the tree. And how, for example, if I construct zero, left is one and right is two, but at some point I'll be needing zero because zero might be left child of something else. So for that, what I'll be doing is so I'll be making a value to node mapping. I'll be storing it in a map basically. So that's how I'm going to do it. So um, in that way, so I'll get the whole tree and but I need to know the root at some point. I need
Right.
to
So you can make nodes, but like the reason to make nodes is to know where the connections are, right? Like, but you already
yeah.
know where the connections are. Like, you know zero's left and right child. So what's the point of the nodes? And like you said, you need to know where the root is. So is there any way you could figure out, like, first of all, let me ask you this: for
Mhm.
a for what I described, can there be more than one root, like valid root? Is there ever a case where I can give you
No. There should not be a valid. Yeah. There can be only one root. So yeah,
right?
if I
So is there any way we can find it?
um yeah um which has both left and right children and okay, let us take this example. So I don't know zero is root. Left, right. Left, right. Okay. So what I can do is like so as I don't know which is the root, so I can give each number levels, just vertical levels. So for zero, if left is one, right is two, so one will have a level of plus one, and two will have a level of plus one.
Mm-hmm.
So and zero will have basically zero. So if I get zero as something's left child, so I give the a root of zero as minus one level. So ultimately, whichever is the what do you say, whichever is the root will have the least value. Either it may be positive or negative, but it'll have the least value on y-axis. So if I go, yeah, so that's
So I
how
think with
I'll
this
know the root.
levels thing, so let's
Hmm.
say zero has a level of zero and then one has a level of one and two. Now the
Hmm.
problem is if zero is a child of something, you have to like update the level of everything, right?
No, I can just reduce it the level, right? So if I know the level of zero, if I have the level of zero in some map,
Mm-hmm.
so zero is at zeroth level, but some three has a left child of zero, so I can make three as minus one, right?
Three
So
has a left
just
child.
redu
Oh, I see.
yeah,
Okay.
because it's the root, yeah. So
Would
yeah, I
that
can just
work? Because you might also have like cycles. Like, what if I give you edges that like make a cycle?
yeah. Mhm.
So you can do something even simpler. Just think about like in a tree, like what can't a root have? Like what are the properties of a root?
It cannot have three children.
It cannot have three children because it's a binary,
Hmm.
but what else can't it have?
Hmm. Um,
Like what can every node have that a root can't?
it cannot be a child of something.
Yeah.
Root cannot be a child of something.
Yeah. So from there, is there like an easier way we could do this?
Okay, let me take this example.
Sure.
So one is a child of something, two is a child of something, and three is a child of two. Three is a child of two. Yeah, right. Okay, so zero is the only thing that doesn't have any children. So that's how I make my root and then start iterating left and right.
Hmm.
So yeah, that's the simple thing. Yeah, is that how I approach it?
Yeah, it makes
Mm,
sense. So let me ask you, what happens if I guess there's a couple cases you can have, right? So you might
mhm.
have multiple roots. So what would you do in that case? Like what if like three nodes don't have any parents?
Three nodes don't have any parents.
Yeah, like if I say n equals
Yeah,
3
I'll
and then the
start
whole thing's
iterating.
3.
I'll do like so I'll have all of my nodes. I'll have a visited array. So whichever is not visited, I'll start iterating from that tree again. So if two individual nodes are separate, so I'll start iteration from there, BFS from there, and yeah, if it's a single node, it's a valid this thing. Oh, it can be separate. You're saying it should be connected or something like that.
No, what I was saying is, so you can find a root just by finding like what node doesn't have any parents, right? Like it can't be a left child or a right child. But what if multiple nodes hit that requirement, right? So basically, like let's say I have like this case, it's like n equals 2, and my arrays are like this. So here, both both 0 and or I guess 1 and 2 don't have any parents. So
I
you'd
get
have like
it.
two roots. So what would this be?
Yeah. So is this a valid tree or not a valid tree? That's my question.
So what do you think?
Those are two individual things. So individually, it's not a connected. So yeah, it's not a tree. Yeah, it's not a tree.
Yeah. Yeah. So it can only have one root. So yeah.
Mhm.
Okay.
Hmm.
But yeah. So you can write
Yeah,
more
yeah.
notes
This is
or
an
you
edge
can
case. This is an edge case. Yeah.
yeah. So you can
So
write more
yeah,
notes
if
or you
I.
could start coding, up to you.
Mhm. So yeah, let me repeat my approach. So if there is only one root, then I just start iterating and find a valid tree.
Mm-hmm.
Otherwise, if I find multiple nodes mm, with them not being children of anything, that means it's not a tree. That's an edge case.
Mm-hmm. And before you start coding, last thing. So what's the time and space complexity of this?
Time and space complexity would be O of n because I'm going through all the nodes. Just a minute. Yeah, I'll be going through left as well as right. Yeah, so I'll be traversing linear time complexity.
Mm-hmm.
And space would be, I'm not creating as such. Yeah, I'm not creating any auxiliary space, so it will be of one.
Okay. Okay. Yeah, you can start coding or you can write more notes. So we're at 17 or wait, we have 35 minutes left. So up to you how you use your time.
Okay, this is the only question, right?
No, there's
I
two.
might be. Oh, there's two. Okay.
Yeah.
Mhm. Going to get left and right children as this thing, right? Okay. Mhm. 1% of the I'll take another function if that's it. Let me estimate the So I'm getting the size of the L array. Hmm, 0 left is 1, 0 right is 2. So how do I make them happen? Oh, I think this just boils down to mm, in degree sort of thing, right? So yeah, so this is a so everything is 0 to 1 is an edge, 0 to 2 is an edge. So I just can have an in degree array and just increase the value of 1, increase the value of 2.
Okay.
Uh, yeah. Yeah, now suddenly it came to my mind. And yeah, whichever have in degree 0, that is the root. Um, if I have multiple values with in degree 0, that means that is not a tree. That's the perfect approach, I think. What do you think?
Sure. I think that works.
Yeah. Okay. Yeah, I have changed my approach. Sorry. Um, oh, okay. Now it becomes easier. I just need to make an in degree array of number of nodes will be n. So n will start with 0. And then what I'm going to do is start iterating. mm, uh, equal to 0. Plus what I'm going to do is in degree of left L right L of I plus plus. So one more thing I need to ask is, are the nodes indexed from 0 or indexed from 1?
From well, you could see from one.
Yeah, from 1. Sorry. Yeah. Okay. So in that case, I think I should maintain an in degree array of n plus 1. I'll just neglect 0 because I
Sure.
don't have any 0th node. Mm, yeah, this should be the case. And L of I, perfect. It should work. So L of I is 1 is plus. At the same time, in degree of right of I plus plus. Perfect. After this, now what I'll do is I'll iterate through the in degree array. If I equal to 0, less than it should be 1 in this case because valid nodes start from 1 less than or equal to n I plus plus. If n degree of I is 0, I'll have to maintain some count. N degree is 0, count plus plus. If I have a count greater than 1, if count is greater than 1, then return false, otherwise return true. Yeah. So, yeah, this is my approach. Mm, so, yeah.
So you found a root, right?
Mm-hmm, mm-hmm.
But how do you know the nodes are connected at all? Or there's no cycle or something? Like, do you think,
Yeah. Okay. Okay. Mm,
like you're basically saying
this
that if
just,
I have a valid root, then this is just always works?
let me think. If this has a valid root, it can have cycles as well. So you mean like you want me to consider the case if there are cycles as well, or
Yeah.
like, um, mhm. If there are cycles, then mhm,
I think we
then
should
I need
move
to.
on to the second problem from here, just because it's been like we only
Yeah,
have
yeah, sure.
27 minutes left, and I want to give you time,
Yeah,
and then we
sure.
can come back to the cycles thing.
Hmm. Hmm.
Okay. So so for the second problem, you have a 3x3 grid, and you're playing a game. So your 3x3 grid has numbers. So you have 9 marbles total. Okay. And you have a 3x3 grid, and there's any number of marbles in every single cell. So for example, a cell might look, or a possible game might look like this: 0, 1, 2, 0, 0, 0, and where we have left 6, so like 2, 2, 2. So this is like a valid game state. Okay, make sense so far?
Yeah. So the numbers are the number of marbles, zero, and
Yeah. So
yeah.
you have 9. So you have a 3x3 grid. In every cell, there's some number of marbles, and you have 9 total.
Hmm.
And a move is taking one marble and moving it to adjacent cell. Only left, right, up, down. You can't go diagonal. Make sense?
Hmm.
Okay. And you win when every cell has a marble. So basically, the end game state should always look like this. And basically, given a game state, return the min moves to win the game. So in this case, for example, I think what would happen is this. So one way I think works is you take that. So there's a marble on the very right, and you move it from here to the top left. So that takes 2 moves. And then each one of those cells that has 2 at the bottom, you move it up, and that's 1 each. So there's 5 moves total. So this would be 5. Does that make sense?
Hmm.
Okay. You can feel free to ask anything.
Hmm. So the values range. So each cell, the values range from what to what?
So you have 9 total. So the sum of
Okay.
every cell is 9.
Oh, okay. Total 9. Yeah, yeah. Now I understand better. Oh, yeah. Total 9. Right. So yeah, it ultimately boils down to so which are ones I don't touch it because um why to move one because it's already one, and I need to basically move. which are 2's to 0. Mm, that should be the case. But there might be multiple 2's. So
There might be
um,
multiple twos, there could be threes, there could be fours. It's just the sum is 9. They could be anything.
oh, it could be anything, right? Okay.
Yeah.
Oh, oh, that's another point. Okay. And the length of the grid is okay. The sum is 9, so the grid is 3 by 3. Okay.
Yeah, it's always 3 by 3.
Mhm. Mhm. Zero should be made 1. So if I have a So ultimately, if I start from any point, I need to find zeros. How many zeros I can reach and mark them as visited so that they need not be visited in the future.
Okay.
So mark them as 1 so that in future they might not be changed. I do a multi-source BFS. I don't know whether that works or not. I need to. So what I'm telling is, so I start from this 2 and find the. Okay, if I find the nearest one, it will be the below one. But in that case, that my answer won't be optimal. Okay. Uh, if I start from here, this becomes 1 and I stop it. This one can get here and here. This one can get here, but this still remains 2. Oh, this can't get here. So, oh, that multi-source BFS, that will not work, I think.
Yeah, I
Mm,
don't think it works because
yeah, it
it's
won't
not
work.
always the shortest path. Yeah.
Mm. Oh, so I try all possible paths in that case because BFS or DFS is nothing but a recursion. So if it does not give me a shortest path, then my next option would be exploring all possible ways and then choosing the optimal way, which
Okay.
boils down to dynamic programming. But Mhm. Let's see.
Yeah, so how would we do every possible way?
Every possible way, as in I start from, yeah, that's also ultimately which are greater than one by one. I should. Oh, All possible ways that. Oh, I think this is just as it is just 3 by 3.
Hmm.
I just need to know the position of each zero, and then basically it's just distance. I think. Mm,
Hmm.
the the calculation of distance using some greedy approach. Okay, if zero is at this position, so two positions away from zero, so two steps, one position, one position, one position. So, but I need to make sure that all are one. So yeah, it is just simply a distance measure. I get it. Mhm. But what if there is 3 and 4, and which one should I prioritize? For example, if I make one one example here, mm, 0, 0, 1, the overall sum should be 7, right? And 1, 0, 3, 0, 0, 4. So this is one case. So in that case, if I have all the zero mappings in a map, mm, for 3, these 4, 3, 7, 8, 9, this can go to the left, 2, 3, and then oh, it can only reach 2 positions. So if I take the nearest distance in this case, so 3 can either make this one 1 and one of these both 1. But mm, first, should I start from 4 or 3? So I start from 4. The nearest ones are these 3, and it will map it. And in this case, these 2. So yeah, I think I should always start from the greater number and then go to the lesser number.
Okay.
Mm,
Well, does it matter where you start? Because you said you'll try like every possible like scenario,
Yeah,
right? So if you
I'm
try every
thinking,
scenario, does it matter?
yeah, if I try every scenario, that doesn't matter.
Hmm.
Mm, every scenario, but how do I try every scenario? I should do a multi. No, I was thinking a different greedy approach basically. So I start from the greater number and make ones whichever I can traverse. I make all of them one, and then start from the lesser number and make them ones. But if I follow the same approach here, I can like choose any two out of these. So if I choose
Yeah.
this two, and if it makes this one, then my optimal case is broken. So greedy will not work.
Yeah, I don't think greedy
Um,
works. Yeah, because like you said, if you pick this top right two, and then you'll go
yeah,
down, and then
the
it's just
and map is 0, then that's gone. Yeah.
yeah. So basically, greedy doesn't really work, and BFS doesn't really work, like you mentioned. But you know where all the zeros are, and you know where all the non-zeros are. So
Hmm.
how could we just try every? And it's a small grid. So how
That's
could we
what
try every
I'm
scenario?
trying a distance mapping, but yeah, I know all zeros are at. That's what was my approach. So all zeros are at these positions. All non-zeros are at these positions. I was trying a distance measure, but it's not. It's failing in this case. Oh, does it matter? You're asking, right?
Yeah, like
Okay.
basically, it's like so if I'm at the
Oh, it's
four.
just like yeah. If you're at 4,
Mhm.
so if you're at 4, then I just need to so this 0 is at 2 positions. this 0 is at one position, this 0 is at one position. Mm. Oh,
I mean, even
okay.
simpler, like you could just so you're basically your recursive case could be like, I'm at this 4. I'm just gonna try to put a 1 somewhere, and
Mm-hmm.
then I'm gonna recurse after that, right? So basically, I could be like, okay, well maybe I'll put the 1 even here, well, even without the greedy. Like I'll just do this, and then
Mm-hmm.
I'll keep recursing until my stuff is all ones, and then I can like come back and like maybe I'll put a 1 instead of there. I'll put it like here. So do you know like an algorithm that does that?
Sorry, I didn't get you. Like, what were you telling? So if it has like this, okay.
So I was basically saying like you can pick any cell that has more than
Mm-hmm.
one and take
Mm-hmm.
one of them and put it into another cell, like maybe this case. And you can
And
calculate
then
how
change
far,
it.
yeah, and then change it.
Okay.
And then you can calculate how far that was. And then later on, once you've explored that whole path, then you could be like, well, instead of that, maybe I'll put the 1 here this time and then change it. And then you could just figure out like what was the best like full, exploration. Uh
Oh, okay. So yeah, I can do that. I can like recurse always. Yeah.
yeah, cuz it's pretty small input, so.
Mm-hmm.
And then
Mm-hmm.
gradient
Mm-hmm.
BFS doesn't work.
And yeah, gradient VFS doesn't work. So yeah, that is the only way. Try always. But
Mhm.
I need to be doing that for all non-negative values, right? So for 4, I need to do always,
Mhm.
and then next again I should start a fresh recursive call for 3 and then do always. So yeah,
Yeah, I
for
mean,
4 if I
it
do.
doesn't matter which one you pick, but whatever you
Mhm,
pick, you can just be
mhm.
like, okay, I'm gonna pick this. Whatever's
Yeah,
non-zero, I'm
okay.
gonna take a marble, I'll put it somewhere, and then I'll recurse from there until
Mhm,
uh, everything is ones, and then I can like come back and like try to instead of putting the marble where I put it there, I'll try to put it in another spot. So you have this
mhm,
like
mhm,
nested recursive tree, and then
mhm,
at the bottom you can just
mhm.
see like how long does this whole thing take, how long that whole thing take. Whatever takes the least, you just return that.
Yeah, yeah, yeah. Whichever I pick doesn't matter, but ultimately I need to start a recursion for 4 and start a recursion for 3 and then just add them, like add the minimal for whatever I get the minimal steps for 4 plus minimal steps for 3. In that way, like if any non-zero values are there, I need to add all those steps and that will be my answer.
So if you do a
Yeah,
recursion from
this I know.
4 and 3 separately, like they depend on each other. So like based on where you put things from the 4, your ability to put things in the 3 will change, right? Like if from the 4 I put something here, now from the 3 I can't put it there. But from the 4, if I put something here instead, now, like
Mhm.
they depend on each other. So you can't just start them
Oh,
separately. So I'm saying like you have to do the
that was
entire
different.
like full
Mhm.
attempt of every single number and then see what you get. And it doesn't matter what node you pick to start with because you're trying every
Mhm.
combination anyway, so it's irrelevant,
Mhm.
right?
Yeah. So what will be my recursion call that I should figure it out? For example, if I start from ij, some random ij, and then I put here. So if I put 1 here, I reduce my value to 3, and then move here. Ah,
Yeah. So have you heard of like backtracking?
yeah.
Yeah. So it's basically
Yeah, I
that.
got it.
Okay.
Mhm. Okay, so I'll be backtracking until all the elements are one. If I until all the non-one values are like gone. So until then I'll be
Yeah. I
doing
mean,
it.
until everything is one, basically. Yeah.
Uh-huh. Okay. Okay. So I'll start. So I'm given a grid basically. So then oh, I'm given a grid. Yeah. I need to return the number of steps, right? Mm,
Mhm.
If I'm getting no calculate size, just indeed website and viewers. Okay. Now what I'll be doing is okay, let me think once more how my recursive call takes place.
Sure.
I have multiple non-one values. So I start from any one of them and then check whatever zeros I can find and then make them one. Count number of steps. So how I can optimally do it? So for example, if I start from any one of them, either three or four. So if four is here, so if I make a move, then wherever I make a move, I need to like pass three and leave the four as one. Mm.
Yeah. So if you
And
if you
yeah,
take
yeah, that's how it works. Because like if I leave four here, if I leave three here again, I need to start from here. So that's what I'm thinking. So how I can do is like, so four, if it goes here, this stays one and this becomes three. And I have three here and I can use this three to make moves here or here. That's how I'm thinking. Yeah.
I don't see you like writing anything, so I'm not exactly
Oh,
sure.
oh, okay, okay. So this is the pencil. So,
Oh,
so
you're in the
if four
drawing.
is,
Okay.
oh,
I didn't know if you were in the drawing or the code or okay.
okay. So what I was telling is, so if I start from this four and if I make a move to this zero, so what I'll be doing is, I'll be putting three here and one here. And then from three, I need to make moves.
Yeah,
Either,
that makes sense.
uh, so that's how I can do. And if it goes here, I can make two. And I can make this two and this one. And from this, I can move two the same
Mhm.
way. Yeah, okay, got it. Mhm. So solve. I start from any one point or multiple points. This recursive call, how do I make it? Start from any one of them. Roles. So I start from any one point. Yeah, that's fine. So I equal to zero. Okay. what I do if I find any then not equal to 1, then start recursive call from there. And then I also pass the grid and try to modify the grid. Pass grid by reference so that modify. Mm. So, and I take a global maximum variable, a global count, which counts the number of steps. And maximum. Count can be local and maximum can be global. Mm, yeah. And hmm, how what I do is now. So yeah, I need to move in 4 different directions. So I'll take x equal to 0, 0, 1, minus 1. Y will be 1, minus 1, 0, 0. And then what I'll do here is or I can take 4 different steps up, down, left, right for int step. So 4 different iterations. New I coordinate is this di and dj.
Okay, so we're right at 50 minutes, so you can stop. And then
Okay.
curious. So before I give you feedback, how do you think you did? And like, what do you think you did
Yeah.
good, and what do you think
I
you can
did.
improve in?
No, I did. I feel I did pretty bad. I don't know what is the reason, but yeah.
Yeah, I agree. I think
Yeah.
so. There are a few areas that like so. There's some easy stuff, and then there's some harder stuff. So
Mhm.
basically, I feel like you got to some of the edge cases, but you happened to get them through like kind of like luck. You were saying stuff, and then you were like, "Oh, by the way, is there this thing?" And then I was like, "Oh, actually, no, it's not like this."
Mhm.
So what I would have said for like, let me just go back to the first problem with these nodes. So I would have asked things like, um, "Is zero the root?" Which you ended up asking like afterwards, like once you were thinking of a plan, and then I was like, "Actually, no." And then the other thing I would have asked for like, "Can you have cycles?" And I think I did tell you that you can, and then you still
Mhm.
had an approach that didn't account for cycles. So
Mhm.
basically, what you could have realized here was, and you sort of did, and you were making this like overcomplicated solution, but what you could have realized was like, okay, so I have a tree. These edges are directed, not directed, because like if B is a child of A is not a child of B, right? It's not both
Yeah,
ways.
yeah.
Yeah,
Mhm.
and you could have realized like, oh yeah, root doesn't have a parent, so I can just like, I think you used in degrees, but you could have done something even simpler. You could have just like put all of them in like a set, and then anytime it's a child, you just like remove it from the set, and then you just check like how many things are in the set. If it's only one, then you know it's like valid. That would have been easier. And then there could have been like two, which is invalid, or zero, which is invalid, or whatever. And then the next part you needed to do was basically you needed to do a traversal from the root using these like pointers and see, can I visit every node, and can I visit every node once? And then that would have told you if that was a valid. But you basically just like found the root, and you said like, if I found the root, then it's valid. But yeah, I hopefully you could see how like a tree, and I can draw this for you real quickly to illustrate. So if you go to the drawing, so one example of an invalid tree with only one root would be like I have a node here. I don't even need like the value. I can just put a circle, and then it goes here, and then it goes here, and then this comes up like this way. So this would be like an invalid tree, right? There is only one root,
Mm-hmm.
but it's still a cycle. So yeah, does that make sense?
Yeah, yeah.
Okay. Yeah. The other big thing that I noticed that I definitely would work on, this is like a general thing, is communication. So you you go into a lot of these like pauses where you're like, okay, I'm thinking, and then for like 2 to 3 minutes you don't say anything, and I'm like, I literally have no idea what you're thinking. And I think especially in a time like now, if you don't say anything for a very long time, people are going to assume you're cheating.
Yeah.
Like it's kind of annoying, but it is what it is. Like so for me, for example, I usually have very good solutions. And so if people think I'm cheating, whatever, but I'm going to try to communicate as best I can to try to illustrate that like I know what I'm doing. So that's the thing I would work on is like I want to know like what are you thinking, what are you planning, and not just have these like big silences. So I definitely work on that. Like one thing you
Mhm.
could do that people said that works for them. I mean, I made videos to explain problems. Obviously, you don't have to do that. You can just record yourself explaining it and then like watch the recording and then be like, okay, if I was the interviewer, am I getting this? And how many like big pauses were there? And then you can kind of notice like, oh yeah, there were like these big. And I'm gonna upload this so you could like fast forward through it and you could see like, oh yeah, there were these like really big pauses and like I could have done a lot better here. Does that make sense?
Yeah. Got it.
Okay. And then yeah, the other thing. So and yeah, I basically tried to hint for you to like, yeah, so you just find the root and then you do traversal. You figured out how to get the root, but then you didn't do the traversal, and then you said the space was going to be O1, and I don't think you can have O1. You need a traversal, or you need
Yeah. That
yeah,
was, yeah. That
yeah.
was like, I think the previous approach, but with the in degree approach, it's off. And yeah.
With any approach to find the root, you can't have it in O1 in degree, visited set, whatever. Like it doesn't matter. It'll always be bigger. So, but yeah,
Oh,
um,
you mean like a recursive, like the stack space OH, that you mean
yeah,
that?
like so.
Oh.
Well, even define the root, right? Define a root. You either need in degrees or a visited set or some kind of data structure to eliminate wrong roots.
Mhm.
So you can't
Yeah.
do that. Yeah, and then to do the actual traversal, will also never be O1. You need a BFS or DFS or something.
Mhm.
Yeah,
Yeah, in that case, it'll be OH. Yeah.
yeah. And then yeah. So when you were coding, also same kind of thing. Like very very little communication. So you definitely need to work on that. Like I need to know what you're doing. Oh yeah, the other thing is you never wrote anything down. So if you look like at the comments, this is basically all of my comments. You basically wrote nothing. So what I would have done is, and this is actually what I usually do, is I'd be like, okay, problem, and then I'd like write some notes here, like asked to find valid root or tree, and then I'd write some like edge cases, and then I'd ask for these things and write them down, right? And be like A, B, C, and then I'd have like a plan, and it'd be like, okay, find the root, DFS on the root or whatever, something like that, right? You want to have things that you write down because then when you code, you can refer to them, and as the problems get harder, you might forget like, so what was I thinking? I don't know. So this helps you do two things. It helps you remember what you did, but it also makes it very clear to the interviewer like what you're doing. The more clear you can be, the more if you deviate, I can be like, hey, but you said you were going to do this and now you did this. Is that a mistake or are you switching? And then it could be a mistake, and then you'd be like, oh yeah, that was actually a mistake. Thanks for correcting me. Or you could be like, hey, I'm switching, and then you could say why, right? I had this, and so then it basically helps like ideally you basically want the interviewer to know exactly what you're doing at all times, and this
Yeah.
helps with that. Okay.
Yeah.
Okay, so for the first one out of five, I'd say like your problem solving was like a 1.5 out of 5 because
Okay.
like I hinted you to get the root, and then even once you got the root, you still didn't like have the full thing. And then DSA, so I also gave it like a 1.5 out of 5 because basically you like weren't sure what data structure to use, and then you landed on this in degree thing, which is fine, and then you also never actually like made a traversal essentially. Like you just like didn't understand like the concept of like if it has a cycle, then I can't just like find a route. So I'd consider that as like DSA. And then coding was kind of low as well, just because I feel like you didn't really have a well. I mean, I guess the coding was okay, but like because like the whole first part was wrong, it's kind of hard to give it like a fair grade. And then the
Mm-hmm.
communication I thought was also not great because, like I said, you had a lot of these big pauses. So definitely the big pause thing is a huge problem, and you need to fix that. The next part is
Okay.
just like think of solutions, write them down, and then the next thing is speed. So I basically had to cut you off at because like so what I would have done was like if you were kind of close to finishing and it was 25 minutes, I would have been like, okay, let's finish, and maybe you have a little bit less problems. But because you didn't do any of the traversal, I was like, this is going to take another like 5 to 10 minutes, and then you'll have like no time for the second problem. So I kind of had to cut you off. So when I give you like, hey, we have 50 minutes to problems, you need to make sure that like ideally you finish the first one in under 25. The earlier the faster, because then you have more time for the second one. So try to hit these time constraints as best you can. Because you basically didn't get to run your code at all. You didn't get to test an edge case. We just didn't get to any of that because it was like too slow. Um, so yeah. And then the second one, so you did restate the problem. Um, you also same thing. You ran into. I think I even hinted this to you, where my example only had ones and twos, so you were like, "Oh, I'll just check for ones and twos," but I just said we have 9 marbles. I didn't say they're all ones and twos. So make sure you don't just take the example and assume everything like that. You know, like if I give you something that's a sorted order, you should ask, "Is it sorted?" Because my example might have that, but like this one on the right that I made with the threes and fours totally fits everything I told you, um, and you didn't check for that thing. So there's a common thing people do with leak code where like leak code just gives you everything and then they don't really have to check for anything. I tried I tried lately to be as vague as I can, and then if people don't ask, they will get it wrong, and then it kind of forces you to ask questions. So definitely get in the habit of that. Like it's not leak code. People won't give you all the constraints sometimes on purpose. It doesn't take a very long time to like get all the constraints. So I would have asked like, yeah, so how big can the numbers be? What's the total and all that stuff, and then yeah. Let's see. Yeah, so I basically said you didn't ask about edge cases, you just happened to do stuff and then accidentally like discovered them because I either hinted or something like that, where you could have asked ahead of time. You did. The good thing here is you did point out a BFS doesn't work. I thought that was good. Most people try to BFS and then I have to give them the counterexample because they don't understand that like BFS doesn't work. Um, but then I kept hinting like, can we just try everything? Can we just try everything? And I was hoping you'd realize like, hey, like if I can't do greedy or BFS because the space is small, I can just backtrack. So I can basically just take any cell with more than one marble and any cell with zero, and then just like fill that and then like recurse to the next. And there's not the biggest time complexity there because like the most cells you can have with more than one marble is like 9, and the most cells you can put into is 9, even be less than that. So it'll be like not that big of a time complexity there. So you can basically just like brute force it. Um, and yeah, you didn't really say the time complexity, and I mean, I didn't want to say like, do you know backtracking? Can we just do backtracking? Because I felt like I did towards the end when we were like really running out of time, but I was trying to hint at it without just like telling you everything. Um,
Yeah, I was just trying to figure how to write the recursive call. Yeah,
yeah, yeah.
that I was
Yeah,
stuck
and
there.
so that's the other part is you got yeah, you were like same thing, communication wasn't great. You were stuck a lot, and then the coding also, yeah, you were like, so I know what I'm doing, but like how do I code it? And it was literally as simple as go through the grid, find a cell with a value greater than 1, then go through the
Yeah.
grid, find a cell with a value of 0 and just put the thing there. Like it doesn't cost you much to go through the grid, it's only 9. You could have optimized
Mhm.
by like storing like cells that were 0 in one space and then cells that were non-zero in another space, maybe like 2 data structures. But it wasn't a big deal. Like going through the grid costs you it's like a 3 by 3 grid.
Yeah,
So
yeah, 9. Often,
yeah, so you
often,
just
yeah.
needed like something working there, and then yeah, I didn't really have anything to write for the coding just because like you struggled there. So that's the other thing is like, so basically the steps I would follow is like a read the problem, make sure you clarify every edge case you can. Very important because sometimes it doesn't matter too much. Sometimes if you don't handle an edge case like that cycle, then your algorithm is completely wrong and that's just a fail. Um,
Yeah. 20 minutes gone to waste. Again, you have to start a new approach. Yeah.
Exactly.
Sometimes.
So this takes like 30 seconds. So yeah, do that. Next thing, come up with a good plan that you and your interviewer can agree on and write things down so that your interviewer can be like, oh, this is what they wrote down. Is this what they're coding? Next thing, code a clean solution. And the next thing, depending on if you can run or not, like dry run with an example, and then like write some test cases and things like that. And then you kind of need one to work to do the other. Like if you do badly on one, then you just like run out of time on the other, and it all goes kind of bad. So that's what I'd make sure. It's like, and then the other thing is speed. So usually, I think when people say that they want to run the code, then I give them like 50 minutes, and if not, then I'll give them like 40, and that's like, I think that's pretty reasonable. I think that's like the meta time and stuff. So, and a lot of people fail on this like time constraint. Like they do pretty well, but then they're just too slow. So yeah, basically there's like a lot of stuff you have to work on, I feel like, but luckily because you're still in college, you can like you don't have an interview next week, so you have a lot of time to like do better and fix these things. And yeah, the other thing is like it's not leak code, so you have to actually clarify these things. Like you can't, some people ask things like, well, is the input like 10 to the 5th roughly? And I'm like, I'm not going to tell you. Like we're not trying to pass a leak code constraint. So yeah. So I think I purposely have been trying to have people hit all these gotchas that like really cost them, that are really, and it's really common that people do this stuff. Like they don't ask for the edge cases, they don't, like they see one example and just assume everything is like that and stuff like that. But all these things are like very small things, and then after that, yeah, you just need to work on like getting the solution quicker and faster, and then coding well and not getting stuck and stuff like that. So so
Yeah.
I'd say on this one,
I
this
do.
was like an obvious no hire, but like I feel like all this stuff isn't like how smart you are. It's just like you do something, you get feedback, you improve, you do it again, you get better. Like everyone starts off, in a bad spot, and then it's all about just like getting better and improving and stuff. So
Yeah.
yeah, do you have any other questions?
Yeah, no. So can we do it again maybe after 1 month or 2 months? Do you take repetitions or like
Yeah,
no?
absolutely. So I basically tell
Okay.
everyone you can do as much as you want. Obviously, don't just like sign up every week for 2 months. But if you want to
Okay.
sign up in 2 weeks or a month, happy to do it again, provided
Yeah.
I'm like not busy with work. But if I'm busy with
Yeah.
work, you can just schedule the week after or whatever. So yeah, no
Yeah.
problem.
Sure. Yeah. Thank you.
Okay, cool. See you later.